Hi, everybody. This is Mr. Dale Campo. It is Friday, November 20. It is 8:07 p.m. This is the day before Thanksgiving break. We're not big fans of giving homework during a break. However, students were struggling through the fractions lesson this week. So we decided we need to give our students more practice. And there's also a milestone test that the students are going to take when they come back from break. So it's really important that you all get your practice. So we are giving this assignment. It is a 3-day assignment during the break. It's called Dividing Fractions the Common Denominator Way. All right. In this video, you're going to see some tips that will help you. And it's going to be a longer video just because some students benefit from having the problems read out loud to them. Okay, so I'll be reading all of these problems out loud. This is a long video, so feel free to fast forward. Feel free to skip parts. Feel free to pause. Feel free to rewind. Okay, so here it is. We're going to go through screen 1. It says, "Dear students, this assignment has 3 sections with a few problems to do over 3 days. Day 1, day 2, and day 3. This means that we recommend that you choose 3 days during this break to work on this assignment. If you need help, please email your teachers during the break, and you can also watch the video on Google Classroom to help you. Please use the 3-read strategy to circle important numbers and info and underline the tasks. The due date for this assignment is Tuesday, December 1, 2020 at 11:59. Now, if you are in Team Bulbasaur, your due date is later because you have math class later in the week, okay? So the 2 different groups have different deadlines. Now, this first part is your day 1 assignment. This first part is your day 1 assignment. Day 1 is fractions on a number line. Number 3 says, where is 1/3? Reminder, we're asking you to put a dot where you think the number 1/3 is. We are not asking about 1/3 of 2. Okay? Now, let me give you some advice on this problem. And the nice thing you can do is we let you draw. You do have the ability to draw where you need to, but we're going to change this problem a little bit. I am going to change this problem to 1/4. Okay. That means I'm not going to give you the answer to the real problem number 3. I'm just giving you an example to try to help you. Okay. So I'm changing this problem just for this video. All right. You still have to do where is 1/3. But for this video, I'm changing it to where is 1/4. Okay. All right. We need to figure out where 1/4 is. Okay. Some of you already know how to do this super quickly, but I want us to understand this a little bit deeper. Okay. Here is a picture of 1/4. First of all, here's my 1 hole, and I'm cutting it to show 1/4. Okay. Here is my 1 hole, and I'm cutting it, shading things in to show you 2/4. Here's my 1 hole, cutting it to show you, and shading it to show 3/4. Okay? Notice that I said I'm cutting 1 hole. Basically, I'm cutting this 1 hole right here. And what I'm saying is from 0 to 1, from 0 to 1 is 1 hole. From 0 to that 1 is 1 hole. Okay? But I'm not trying to shade 1 hole. I'm trying to figure out where is 1/4. Where is 1/4? Where is 1/4? Okay? Well, I just have to, the good news is I just have to do the same thing I've done in my other pictures here. I'm taking this one hole and I'm cutting it into fourths. Then, right over here at this line is where 1/4 is. Right over here at this tick mark, they call this a tick mark, this is where 1/4 lives. And I'm putting a dot right there, and I am officially done. That is the answer. Here's 1/4. Okay? All right. So hopefully you all understand that this dot over here represents 1/4, and I've answered the question, where is 1/4? Okay? That is just an example. As I said, your job, let me see if I can erase all of this. Your job is to do this problem. Okay? Your job is to do that problem. All right? Now, I'm going to now get out of number 3. And I'm going to talk about number 4. Number 4, where is 4/5? Reminder, we are not asking you to put a dot. We're asking you to put a dot where you think the number 4/5 is. We are not asking about 4/5 of 2, okay? This problem is the same as it's very similar to number 3, okay? But I won't go over strategies for 4 because it's the same strategy for number 3, okay? You're doing a similar thing as you did in number 3. Number 5 is also similar to number 4 and 3. Where is 5/4? Reminder, we're asking you to put a dot where you think the number 5/4 is. We are not asking about 5/4 of 2. Okay? Similar strategy as the last problems. Day 2. Day 2, dividing fractions, word problems. So this is similar to the work that we did this week. Okay? On Zoom, and similar to the work you did on Monday, Tuesday. Please use pictures to solve these division problems on pages 7 and 8. Okay. I'm going to change, so in order to teach you all a little bit here, I'm going to change this problem again, okay? Let me just change this problem to 3. And I'll leave the half, okay? Now here's the thing. It says here, please draw a picture below. Draw any picture that helps you. That means you don't have to use my shapes. If you want to do this with circles for the cookies, do it. Okay? If you want to use rectangles or squares, do it. Whatever shapes help you, okay? Your picture might be different from mine, and that's totally okay. Now, we talked about the 3-read protocol, and that is very helpful for doing long word problems or just word problems in general, okay? So 3-read protocol is basically circle anything that you think is important and underline what the task is, okay? So if you need to, read this 3 times or more and circle important information and underline the task, okay? So you're going to see me practice that right now, okay? And we're going to pretend that I read this already 3 times, okay? I read this problem 3 times. I know that we need to figure out how many half cookies can he make, okay? I know that we're talking about half cookies or 1/2 cookies. So I'm circling that because it's important. I also know that he has 3 whole cookies. Anthony has 3 whole cookies. So I'm also circling that. Again, I've circled important information, and there are 2 pieces of important information. The half cookies, and he has 3 whole cookies. Okay. In fact, I think it's really important to know that he does have 3 whole cookies. So I'm actually going to circle this whole thing right here. Remember, I changed this to 3 for this example. He has 3 whole cookies. So I'm circling the whole thing right here. All right. Why do we do the 3-root protocol? It's because so that we know what the important information is. Okay? All right. How many half cookies can he make? And I know he has 3 whole cookies. All right. So, I'm going to draw a circle for the first cookie, another circle for the second cookie, and another circle for the third cookie. All right. Wait a minute. How many half cookies can he make? Okay. Well, I know that this is a picture of a half. This is a half cookie. All right. So my job is to take this picture on top of these 3 cookies and figure out how many halves are in these cookies. How many halves are in these 3 cookies? Okay. Because we're trying to make half cookies. All right. So here we go. I'm going to cut this cookie in half. Here's a half cookie. Here's a half cookie. Here's also another half cookie and another half cookie and another half cookie and another half cookie. Okay. Go back to the question now. How many half cookies can he make? Well, here's 1 half cookie. Here's 2 half cookies, 3 half cookies, 4 half cookies, 5 half cookies, 6 half cookies. Okay. So what you would type, let's see if I can move this. What I would type below here is Anthony can make, how many half cookies did we get? So I'm going back to the picture. 6. Okay, Anthony can make 6 half cookies. Okay, so that's what I would add right below. All right, you could have done this with rectangles or squares or any other shape as well. All right. So I am not giving the answer to this problem. I'm giving you the answer to a different problem and a strategy for doing a different problem. Okay, so your job is to do this problem. Okay, he has 5 whole cookies. Please do this problem with 5 whole cookies. Okay. So remember, the problem that I just did is different from this problem, and you have to do this problem. Okay. I hope that's clear. All right. Page 8, number 8. Ariana is donating hot chocolate to the homeless this Thanksgiving. 1 thermos of hot chocolate uses 2/3 cups of cocoa powder. How many thermoses of hot chocolate can Ariana make with 4 cups of cocoa powder? Okay. Again, if there's any important words, if there's any important information, please circle it. And we want you to underline the question. This is the 3-read protocol. Okay, the 3-read protocol has two parts. You're circling important information, you're underlining the question, and you're reading this problem 3 times or more. Okay. All right. What pieces of information are important? Ariana is donating hot chocolate to the homeless this Thanksgiving. 1 thermos of hot chocolate uses 2/3 cup of cocoa powder. I think it's also important to know that we're talking about 1 thermos. So, in fact, I'm just going to keep those 2 facts together. 1 thermos, 2/3 cup. Now, here's the thing. You notice that I've been writing on this whole thing, okay? Please definitely take advantage of that. Now, here's this 1 thermos right here. And in fact, if you can look at the black writing over here, it says thermos. Okay, this is 1 thermos. And I want you to imagine that inside this 1 thermos, sorry, let me change my pen. Inside this 1 thermos is 2/3 cups. 2/3 is a 2/3 cup of cocoa powder. think this should be an S here, actually. 2/3 cups of cocoa powder. Okay. So every thermos has 2/3 cups. See another thermos? It should have 2/3 cups. Ariana grabs another thermos. It should have 2/3 cups. Okay. How many thermoses? So now, again, we said underline the question. How many thermoses of hot chocolate can Ariana make with 4 cups of cocoa powder? Okay, how many thermoses of hot chocolate can Ariana make with 4 cups of cocoa powder? All right, so as you're doing this problem, we're going to figure out how do we represent 4 cups? Okay, how are we going to represent 4 cups? One way to represent 4 cups is maybe you might draw a rectangle. Here's 1 cup. Here's another cup. Here's another cup. Here's another cup. Okay. That's just one way to do it. Some of your classmates earlier this week also did number lines. They might say, hey, here's 0 cups. Here's 1 cup. Here's 2 cups, 3 cups, 4 cups. All right. Now, 1 thermos uses 2/3. Okay. So here's my thirds, but I want 2/3. Here's 1/3, 2/3. Okay. 2/3 cups for 1 thermos. 1 thermos. Okay. 2/3 cups for 1 thermos. Sorry about the writing. This is where I go back to the question. How many thermoses of hot chocolate can Ariana make with 4 cups of cocoa powder? Okay. How many thermoses of hot chocolate can Ariana make with 4 cups of cocoa powder? All right. So now this is where you need to start figuring out, like, how many 2/3 can we make from this entire thing? From this entire thing, how many thermoses? Okay. So now, let me just use a different color here. All right. Well, one thing I can do is cut this into thirds, into thirds. Okay. And here's 1/3, here's 2/3. Remember we said 2/3 makes 1 thermos? Well, wait a minute. Yeah, this is 2/3 right here. And this is 1 thermos. Okay. Watch this. Here's another 2/3. Remember we said, if you look at the bottom, 2/3 is 1 thermos. Here's another thermos. And notice too that how much I'm labeling. Look how I'm labeling these pictures with words. Labeling helps you understand, okay? So don't be afraid to put words. Label it with words, and that'll help you, okay? Now, what about this? This is another thermos. Why? Why is this another thermos? Because this can also represent 2/3. If you put this together, it's also 2/3. So this is another thermos. Okay. Keep going with this problem, and hopefully, if you keep on going with this problem, it'll help you figure this part out. Okay? Because your job is, Ariana can make how many thermoses? So see if you can figure that out. All right, we're gonna go on to over here. Day 3, common denominator strategy. In the last 2 problems, you use pictures to solve division problems. But on the next pages, you will use something different from pictures. This different strategy is called the common denominator strategy. All right, so we're going to be doing similar problems, but now we're using a different strategy. Fill in the pail. The only thing to do on this page is to read and understand. So we're not doing anything really. However, if you want to underline stuff, you can, or circle. This pail can hold 3/4 of a gallon of water. This pail can hold 3/4 of a gallon of water. Brian has other different smaller containers that can hold 1/8 of a gallon of water. All right, I'm just going to draw a smaller container. I'm a very visual person, so don't be afraid to do drawings if you like looking at pictures. This pail can hold 3/4 of a gallon of water. Brian has other different smaller containers that can hold 1/8 of a gallon of water. GAL means gallon. Brian wonders, how many containers of water do I need to completely fill in the pail with water? So, how many of these does Brian need to fill in this whole thing? We will answer that question for you by using the common denominator strategy below. And sorry about the word below, it should be this thing right here. The common denominator strategy is one way to divide a fraction by another fraction. Try to make sense of this new strategy called the common denominator strategy. Write a division equation for the situation. And that's what they wrote, 3/4 divided by 1/8. Do you see why they wrote 3/4 divided by 1/8? What's over here? 3/4, 1/8. And do you also know that they're trying to figure out how many 1/8s go in 3/4? How many groups of 1/8 can make 3/4? The two numbers don't have the same denominator. Yep. In fact, they're different because it's a 4 and an 8. So it's hard to say how many of the second number are in the first number. So we convert both numbers to the same denominator. Huh? So the question is, So the question is, here's a question for you all. How did this person go from 3/4 to 6/8? How did this person change from 3/4 to 6/8? Well, whenever we're talking about two fractions that are equal to each other, we can use multiplication. Oh my goodness. We can use multiplication. Okay. Multiplication is going to help us make two equal fractions. All right. So how did this person go from 3/4 to 6/8? Basically, they multiplied by 2. Take this 3, multiply it by 2. Take this 4, multiply it by 2. And they get 6/8. 3/4 is the same as 6/8. So that's why they went from here to here. And I would do this work on the side somewhere. Okay. So now, look over here. 6/8 divided by 1/8. Now that is the same thing as saying how many ones make 6. How many ones go into 6? How many groups of ones go into 6? 6 divided by 1 is 6. Question, where did they get the 6 and 1 from? Where did they get this from? They got it from the numerators. So these are just your numerators, which are the top numbers. 6 and 1 are your numerators. So basically, what's the final answer? The final answer is in this box. The final answer is just 6. So if you go back to the original problem, which was right over here, the answer to this problem is 6. And that's why they wrote this thing. Okay? This is called common denominator strategy because common denominator means same denominator. And so all they did was take this problem in the beginning and make the denominators the same. Make these denominators the same. And in this example, the denominator was 8. Okay? So they said, hey, I want to make this have an 8 also. So if I'm going to change this 4 to an 8, I'm going to multiply by 2 to make 8. Okay? 3/4, change it to 6/8. And now I can just say, hey, how many 1/8 go in 6/8? How many 1/8 go in 6/8? And in fact, if you want to visualize it real quick, let me see if I can do a really quick picture of it here. All right, this is 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. Okay, so here's my drawing of 6/8. 1/8, 2/8, 3/8, 4/8, 5/8, 6/8. Okay, how many 1/8 are in 6/8? How many 1/8 are in 6/8? How many 1/8 are in 6/8? 1, 2, 3, 4, 5, 6. That's why they did 6 divided by 1 is 6. And that's why, wait, how many 1/8 are in 6/8? That's why this is 6. Okay. I hope that makes sense. So this is the common denominator strategy. Okay. You're going to be using this common denominator strategy to help make sense of this one here too. Okay. Ariana's hot chocolate again. This problem is the same problem as page 8. So you can literally go back to 8 to refresh your memory on what happened there. Okay. You use pictures to solve this problem in number 8. But now you will solve this problem differently. Now, please solve this problem using the common denominator strategy. Common means same. So common denominator means same denominator. Okay. Now, we start off with what we had last time, which was 4 2/3. Okay. Now, if you notice this next line here, a fraction goes here. So we have to figure out what fraction goes there. Okay. For some of you already memorized that 4 is the same thing as 4/1. But why? Why is this true? Because 4. So wait, why is this equal? Because 4/1 is the same thing as 4 divided by 1. And 4 divided by 1 is 4. Okay? So what we're saying is this is the same as this 4 divided. Oh, sorry. Rewind. This thing is the same thing as this thing, which is equal and the same thing as this. So, what was the point? We're saying that this is the same as this. 4/1 is the same as 4. 4 is the same thing as 4/1. 4 is the same thing as 4/1. Okay? So really, I just changed this to this because they're equal. Okay? Now, you got to use the common denominator strategy. Okay? So now your job is to make this the same as this. This needs to be the same as this. Okay? You could either change this fraction. Oh, wait. Rewind. You need to think about which fraction you're going to change. Are you going to change this fraction and make this 1 the same as 3? Or are you going to change this fraction and make this 3 the same as 1? Or are you going to change both fractions and try to change this number to a different number and this number to a different number? There's a lot to think about here. Okay. Here's a hint right here. I'm going to change this 1 change that 1 to a 3. Let me show you with numbers. I need to change this 1 to an equal fraction to a 3. How do I change this 1 to a 3? And it goes back to what we said earlier in an earlier problem. I need to multiply by something. And I also need to multiply by something. Okay? Whoops. I am just messing this up today. I'm so sorry. All right. So what do I do then? Well, this is going to be a 3. This is also going to be a 3. 4 times 3 is 12. Okay. What did we just find out? We just found out that 4 over 1 is equal to 12 over 3. So 4 over 1 is equal to 12 over 3. And I'll just keep the 2/3 the same. All right, so why did we do this? What was the point? It's because now, look, these are common denominators. I'm cheating because I can draw on the side like this. You can't. These are common, oh my goodness. These are common denominators. Okay? Common denominators mean same denominators. All right? Now, the question, so now if you look at this together, basically this is saying 12 over 3 divided by 2 over 3. This is also saying how many 2/3 go in 12/3. How many 2/3 make 12/3? How many of these 2/3 do I need to make 12/3? And we're really also just asking this question. What's 12 divided by 2? What's 12 divided by 2? And whatever that answer is, it's going to go over here and you're done with that problem. Okay? Now, one last thing. If this part right here is confusing you, and if this part is also confusing you, I would draw 12/3. I would literally figure out a drawing where you would draw 12/3. I would draw 12/3 and then figure out how many 2/3 are in 12/3. How many 2/3 are in 12/3? Is it really 6? Because that would be the answer for that. Okay, so think about that one, okay? Sorry, I'm going to try to erase here. Okay, wow, it just disappeared. All right, for number 12, so number 12, page 12 is similar to the last page, okay? Again, use the common denominator strategy to solve this problem. Common means the same, so common denominator means same denominator. Use the sketch pad below only if you need extra space. Okay. I won't go through this one because it's similar to the last one. So good luck with this one. Use the common denominator strategy to solve this problem, and there's the problem. Common means same, so common denominator means same denominator. Use the sketch pad below only if you need extra space. I won't go over this one because it's similar to number 11, which we talked about in this video. Lastly, use the common denominator strategy to solve this problem. Use the sketch pad below only if you need extra space. Okay. I won't talk about this problem either because it's similar to number 11. But anyway, I'll just leave it like that. Okay. Thank you so much. I hope this video was helpful. If not, please again contact us during Thanksgiving break. Really try to work on this during break so that um, you don't get. We don't want you to feel behind with work, so it's really good idea to work on this during break. All right, take care. Have a wonderful Thanksgiving holiday. I hope you have a chance to relax and enjoy. Take care. Bye.